Hey grade 7, welcome to a new unit focusing on data management, which is the collection and the interpretation and display of things like surveys and censuses, as a way to communicate. And so we're gonna go through a bunch of different activities. Today what we are going to be looking at is something called collecting data. So our goal then is to be able to organize information from survey samples into tally/frequency tables using something called primary and secondary data. And so I need to give you some definitions to start with. So samples are a part of a population that is used to make predictions about the whole population. The population itself is the total number of individuals or items. The frequency is the number of times that an event or item occurs. Primary data is information that you collect yourself, and secondary data is information that's collected by someone else, but that you still are able to use. And so we're going to be using those definitions just initially to create some different charts to display different kind of data. It's important in your data collection to remember to avoid something called bias. Biased results, it's when the results of a survey, like if you go out and conduct a survey, when your results of the group that you asked are not going to be representative of a larger group. So let's say, let's say that you want to find out what people's favorite fast food restaurant is, and you decide that you're going to ask 400 people, let's say, and you want those 400 people to represent the population of Waterdown. Okay, so you can say, like, I asked 400 people, and they told me, and I can base what they told me to say, like, Waterdown prefers this fast food restaurant. If you stand outside Pita Pit, or if you stand outside McDonald's or something like that, and you ask 400 people coming out of McDonald's what their favorite fast food place is, they're likely going to say whatever restaurant they're just coming out of. Not necessarily, but it's more likely. Which means that you're going to get a result that's called biased, because it's not going to be accurate. It's going to be what's called skewed. So let's just imagine this scenario for a second, where someone says, and I'll just put it up, and I'll actually just zoom it in for a second. There we go. So let's imagine Peter says, I think we should try an experiment where half the school could start at the regular time and the other half could start an hour later. We could see if there are fewer students in the school group who are late for school. So Jasleen says we should do some research. If we find other schools that have a later start than us, we can ask them what the good and bad points are. And then their teacher says, but what works for another school may not work here. So Heather pipes in and says, let's survey all the grade 7 students to find out their opinions. We could use actual quotes to support our proposal. So the teacher responds, that's a good idea, Heather, but you might get what's called biased results. We have students from kindergarten to grade 8 in this school. The grade 7 students may not have the same sleep patterns as younger students do, and they may not be they may not be a good sample of the entire population. So then Zach says, well, why don't we take something called the census, which is when you ask the entire population. We can make a questionnaire and give it to every student in school. And then Ms. Chan says, I think most students will want to start later, but I'm not sure if their parents or teachers will. We have to get these opinions too. So when you design this kind of stuff, you want to make sure that your results are going to accurately reflect enough people. So that's how you try to avoid biased results. Okay? So what I'm going to show you now are a couple of examples. And this is something called a frequency table / tally chart. And what it looks at bicycle color preference. And it's quite simple, actually. It's broken down into 5 different colors, and then whoever conducted the survey asked a certain number of people and put their responses into tallies. So everyone who said blue got a little tick, or green, tick, white, tick, and so on and so forth. The frequency chart, all we have to do is take the tallies and turn it into numbers. So here there's 8, here there's 5, 10, 15, 17, here's 11, this is 20, and then this is 9. And that's all we really have to do for a frequency chart. You take the number of tallies and you turn it into a number. That's it. Now, what I did was I thought I would take this example a little further. And here, and I got to zoom out a little bit on my screen. Here what I have, this is a really big frequency table. And what I did was I took a paragraph out of the textbook, I think it's on page 302, and I counted up all the letters in that paragraph. It was only about 7 or 8 lines long, so I counted all the letters and then put them into a frequency chart after I counted up all my tallies. And I got a total of 228 letters in that paragraph. And what I'm going to actually get a chance to do in just a second is to compare them and use some of the data that I collected, this primary data, and compare it against some secondary data, which is stuff that I didn't collect, and see how my data compares to the secondary data. So I'm thinking about this stuff in terms of where the letters are placed on a keyboard. Because it's not just A, B, C, D, E, F, G, H, I, J, K, and so on and so forth. It's random where the letters are. It's called the QWERTY keyboard. And so what I'm going to show you is the second part. Now it's a little hard to see, so I'll zoom in on a couple parts. What we have here, this chart shows the letter frequencies in English per 1,000 letters. So all the numbers here add up to 1,000. And you can see which numbers or which letters occur most frequently. You see that out of 1,000, you would have 130 of them typically are E's. This is sort of the averaged out numbers. What I have here, and I can probably zoom in on this a little bit more, as I have this other chart where I have the letters in each row according to the chart that's up here. And so in the top row, out of 1,000, there are 540 letters. Which, as a percent, 540 out of 1,000, or 54 out of 100, or 54%. The home row has 299 letters, which is approximately 30%. That's what it says here. And then in the bottom row has roughly 16 out of 100, which is roughly 16%. So when you add up all those, you get 100%. Now, what I want to do is see how my primary data compares to this secondary data that I've seen. So, what I see here is that I have 123 out of the 228 of the ones that I compared. So that becomes, I get on my trusty calculator, and it becomes 123 divided by 228 times 100 gives me, actually, rounded to the nearest whole number, gives me 54%. So right there, I'm spot on. Exactly what I have, okay? The next one becomes 78 out of 228. So I use my calculator again, 78 divided by 228, which gives me, times 100 then, which gives me 34%. A little higher, but still statistically close. Last thing I have here is 227 out of 228. Which gives me approximately 12%. And so again, these numbers, 30 and 34 and 16 and 12, they're pretty close. So statistically, the paragraph that I counted up is pretty close to the overall average per 1,000 letters. So it's pretty close. Now, the questions that you're going to be working on today are going to be things like put stuff into a frequency table, count up the number of this, that, or the other thing, rank something in order. So what I've talked about here, you should be able to help you out with the practice that you're going to be working on. So have a great night.